Section 2.6, rational functions and their graphs. Let's look at limit as x approaches -1 from the right. So -1 from the right going down to negative infinity. -1 from the left is going to positive infinity. 2 from the right, positive infinity. And 2 from the left is negative infinity. Find the vertical asymptotes, if any, and the values of x corresponding to holes, if any, of the graph of each rational function. So vertical asymptotes and holes. Well, this factors into x plus 5, x minus 5, and we have x minus 5 in the denominator. Those cancel, so we have a hole at the point 5, 10, because if you put 5 in for what remains, you get 10. On this one down here, this is x plus 6 over x plus 6, x minus 4. So we have a hole at x, at the point. Let's get the point. Where does it say? Find the vertical asymptotes. Values of the x corresponding to holes. So they just want the x. Hole at x equals, if you cross those out, at x equals -6, and a vertical asymptote at x equals 4. Find the horizontal asymptote, if there is one, of the graph of each rational function. So the bigger power is in the denominator, so that's an automatic y equals 0, because as you go to infinity, the denominator will be infinitely bigger than the top. So 1 over infinity is actually 0. This one is y equals -3/5 because the powers are the same. They're 1. Exercise 57 to 80. Follow the 7 steps on page 390 to graph each rational function. Well, let's do this. Let's go x-intercepts. That's what makes the top 0. So 0, 0. And so the y-intercept, if you plug 0 in here and here, you get 0 over -1. That's still 0, 0. So 0, 0 is the x and the y-intercept. Let's go with vertical asymptotes. And we're going to factor the denominator. So x equals plus or minus 1 is where vertical asymptotes are. So right here and right there. Horizontal asymptotes. We have the bigger powers in the denominator, so y equals 0. Right there. And then we need some points. So how about -2? And, -1/2. How about +1/2 and 2? So let's put this into the factored form of 4x over x minus 1, x plus 1. So -2 would be -8 over -3 times -1. So -8 thirds. So -2 and 2/3. 2 and 2/3, 2 and 2/3. So -2 and 2/3 right here. So we're looking at something like that. How about -1/2? So -1/2 of 4 is -2 over -3/2 and times what? 1/2, like that. So -2 over -3/4. So that's going to be positive 8/3. So positive 8/3. So 2 and 2/3. So a half is 2 and 2/3 up here. And then 1/2 would be, let's see, half of 4 is 2 over 1/2 minus 1 is -1/2, and 1/2 plus 1 is 3/2. So -2 over 3/4, multiply top and bottom by 4, -8 8/3. This is -8/3, which is -2 and 2/3 right here. So down the middle, it's doing something like this. And then finally, let's go with 2. We have 8 over 2 minus 1 is 1. 2 plus 1 is 3. A lot of 8/3 going on. Positive 2 and 2/3. So it probably looks like something like this. Let's go with x-intercepts on number 68. X-intercepts, that's where the top is 0, so none. Let's go with y-intercepts. let's plug 0 in for x. So 0, -2 over -2 is 1, so 0, 1. We do have a y-intercept, no x-intercepts. Vertical asymptotes. Well, let's factor this, -2 over x minus 2, x plus 1. So we have vertical asymptotes at x equals 2 and x equals -1. So 2 and -1. Now, it does something like this because there's no x-intercepts, so it has to do that in the middle. So the extra points we need are -2 something, and how about 3 something? So for -2 is -2 over -4 times -1. So that'd be -2 over 4, so -1/2. -1/2. Like this. Y equals 0 is a horizontal asymptote, by the way, because the bigger power is in the denominator. And then 3 is -2 over 1 times 4, so -1/2. So -1/2 over here, and it looks like that right there. Let's factor x minus 3 over x minus 3, x plus 3. So those cancel. So we have a whole at 3 and 1/6. 3, 1/6. So 3 and 1/6. So there's a whole about right there, let's say. Well, what's left is 1 over x plus 3. So let's go with x-intercepts. That's what makes the top 0, none. Y-intercept, that's where you plug 0 in for x. That's 1/3. So 1/3. There's a vertical asymptote at x equals -3. That's right here. There is a horizontal asymptote, the bigger power is in the denominator, at y equals 0. So it does something like this. And we could get it more accurate than that, but we don't really need to. And then how about, let's plug in -4. So 1 over -1 is -1. So -4, -1 right there. Let's go with x-intercepts. That's what makes y 0, but how do you make a fraction 0? You make the top 0. So 0, 0. Y-intercept is also going to be 0, 0. Because we plug zeros in for all the x's. Zeros in for all the x's. That's 0 over -6. Let's factor this. X squared over x plus 3, x minus 2. So vertical asymptotes at x equals -3 and x equals 2. Horizontal asymptote at y equals 1, because we have x squared over x squared. Like that. Well, we're going to need some more points here. So we're going to need -4. We'll need, let's go with -2. We have 0. Let's go with 1. We better do that one. And because this can do a lot of things, and I'm going to erase this. This could do this. This could do that. It could do that. There's lots of things that this could do. So that's what we're trying to figure out now. Yeah, so we got -2 and 1. Let's go with, how about 3 also? So -4, that's going to be 16 over -1 times -6. So 16 over 6, 8 over 3. So 2 and 2/3. So -4 is 2 and 2/3. Pretty sure it does that action right there. -2 is 4 over 1 -4. So that's going to be -1. -2 is -1. What's 1? 1 over 4 times -1. -1/4. So that's -1/4 here. So it's probably doing something like that. 1, oh wait, did I do 1? That's the negative 1/4. Yeah, negative 1/4. Then 3 is 9 over 6 times 1. So 3 halves. So 1 and 1/2. So 3 is 1 1/2. Like that.